Hello, good day viewers. Let us integrate this function. The function is x to the power of 3 plus 4x squared plus 6x plus 9 divided by x squared minus 9 multiplied by x minus 6 with respect to x. The first thing I want us to do here is to reduce the function. Let us factorize the top first. I can factorize this as x to the power of 3 plus 4x squared can be written as 3x squared plus x squared. Then 6x can be written as 3x plus 3x, then plus 9. Why do I split the function like this? Because I want to factorize in batches. And you can only factorize in batches if the respective batches have the same ratios. You can see 9 divided by 3 is 3, 3 divided by 1 is 3, 3 divided by 1 is 3. This is the only condition you can factorize in batches. I will factorize the first two, second two, and the third two, right? So the first two, we have x squared in common. So we have x squared here multiplied by x plus 3. Then the second one, we have x in common multiplied by x plus 3. Then the third one, we have 3 in common. Inside we have x plus 3. Now that we have x plus 3 in common, we can bring 1 out. X plus 3. Then from the first term, we have x squared left. From the second term, we have x left. From the third term, we have 3. So now we have just factorized the top. What about the bottom? The bottom, we can only factorize x squared minus 9. And x squared minus 9 can be factorized as x squared minus 9. This is the same thing as x minus 3 multiplied by x plus 3, difference of 2 squares. So now from these two factors, you can see we have common factors, x plus 3 and what? X plus 3. So they'll cancel. From the top, this is what we have left. So let's write it. We have x squared plus x plus 3 to the top, divide by x minus 3, but we have another factor, right? Which is x minus 6. X minus 6. But if you observe, both the numerator and denominator have the same degree 2, 2. Because if we expand this, you're going to obtain a quadratic function, right? Likewise, this is a quadratic function. Both have a degree of 2. So we can also reduce this using long division. This is equal to x squared plus x plus 3. And if you expand this, you're going to obtain x squared minus 9x plus 18. So this is what we need to divide. Let me bring it aside. To divide this function by long division, our dividend, which is inside, is the numerator, x squared plus x plus 3, and the dividend is outside. We have x squared minus 9x plus 18. X squared can go into x squared one time. So you bring the 1 to the top. Then you multiply 1 by all of this function outside. 1 times x squared is x squared. 1 times negative 9x. 1 times 18 is 18. Then you subtract. From the left hand side, you have x squared minus x squared is 0. Then x minus 9x is 10x. Then 3 minus 18 is negative 15. Therefore, the whole of this that we have just divided, let me copy it. this is equal to the quotient, which is 1, right, plus the remainder, which is 10x minus 15, then divide by what? X squared minus 9x plus 18. And 10x minus 15 is also the same thing as 5 multiplied by 2x minus 3. So let's just reduce it. This is the same thing as 1 plus 5 multiplied by the whole of this 2x minus 3. If you expand this, you're going to obtain this back. Then divide by this. You know, this can be factorized as well because we have it here as x minus 3 multiplied by x minus 6. So we have x minus 3 multiplied by x minus 6. Next, we are going to split this using partial fractions. So let's do that. I only want to take this, which is 2x minus 3, divide by the whole of this x minus 3 multiplied by x minus 6. This is equal to, you can see the denominator are all linear factors. So we have a divided by the first one, x minus 3, then plus b divided by the second one, x minus 6. And to save time, I'm going to apply cover-up method. So let's start by finding the value of a by considering the factor x minus 3. We are going to think of a value of x that can make x minus 3 equal to 0. It is only possible if x is equal to 3, right? So a will be equal to, substitute that 3 here, you have 2 times 3 is 6, and 6 minus 3 is equal to 3. So you have 3 divided by. Then you substitute the other 3 here. You have 3 minus 6, which is negative 3. So you have negative 3 here. And this is equal to negative 1. From here you can see we have negative 1 divided by x minus 3. Then plus the other one. To find the value of b, you are going to consider this factor x minus 6. And the only value of x that can make this 0 is 6, right? So we're going to substitute for b here. We're going to substitute that 6 here. You have 2 times 6 is 12. And 12 minus 3 is 9. So you have 9 here. Divide by. Then you're going to substitute the 6 in this factor, not this one. You have 6 minus 3 equal to 3. Therefore, b will be equal to 3 because 9 divided by 3 is 3. So you have 3 here. Divide by x minus 6. So now let's just bring everything back. This is what we have. This will be equal to, remember from here, we have 1 plus 5 times the whole of this. So we have 1 plus 5 multiplied by what? Our partial fraction, which is, I can write this one first. 3 divided by x minus 6. 3 divided by x minus 6. The minus 1 divided by x minus 3. So this is the same thing with this one. But remember, we want to integrate this function. So if you integrate this, you have to integrate the right hand side with respect to x. So to the right hand side, we have the integral of 1 with respect to x plus the integral of what? I can bring the 5 outside. The whole of this 3 divided by x minus 6 minus 1 divided by x minus 3 with respect to x. If you integrate 1 with respect to x, you're going to obtain x. So this is equal to x plus 5 multiplied by the whole of this. If you integrate this, you're going to obtain 3 multiplied by the natural log of the absolute value of x minus 6. So this is 3 multiplied by the natural log of the absolute value of x minus 6. Then minus the other one, natural log of the absolute value of x minus 3. Then plus the constant of integration. Now let us distribute this 5 inside. This is x plus 15 times the natural log of the absolute value of x minus 6. Then minus 5 times the natural log of the absolute value of x minus 3. Then plus c. So now we can apply one of the laws of logarithm and transform these two terms into a single log. So this is the same thing as x plus, and you know that 15 can serve as a power of the argument, likewise this 5, right? So we have the natural log of x minus 6 to the power of 15, divide by, because we have negative sign, if it is plus you multiply, x minus 3 to the power of that 5. Then plus the constant of integration. So therefore, if you integrate the whole of this function right here, you're going to obtain x plus the natural log of x minus 6 raised to the power of 15 divided by x minus 3 raised to the power of 5, then plus the constant of integration. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.